And while we're having so much fun, we should also talk about interannual climate variability. These are changes of the climate from one year to the next on time scales less than 10 years. And this is what we call interannual climate variability. And the lecture has three parts: an introduction, where I give you a definition. I introduce you to modes of interannual climate variability and climatic indices. The second part describes the key modes of interannual climate variability, namely the North Atlantic Oscillation, NAO, the El Niño Southern Oscillation, ENSO, also mentioning the Pacific Decadal Oscillations, PDO, because it's linked to ENSO, and the Indian Ocean Dipole, IOD. These are the key modes. In the third part, I discuss global warming slowdowns and accelerations in the context of interannual climate variability. Okay, let's start with the introduction. Okay. The definition of interannual climate variability: it's the variation of a monthly or annual mean value of a climate variable from one year to the next with a periodicity of 2 to 8 years. We're talking about an oscillation. Something that looks like this. I'll show you one example here. Just a made up. On the right side is a little curve here. Shows of changes in the average April temperature of a made up region. Okay, the average temperature is 20 degrees, but it's not always the same. In some years it is higher, and in some years it is lower. And it's an oscillation, a cycle that has a certain period, time scale. Okay, in this example, it's actually a little bit more than 10 years. Okay, so that's what we're talking about. And it's very important to know about these different modes of interannual climate variability. But what do we mean by mode? What is this mode? So what are modes of interannual climate variability? So this concept of climatic mode is based on the decomposition of an observed mean value into a sum of individual components. Sounds complicated, but essentially, if you write down a little equation, on one side you have the observed value. Okay? The observed value, like the average April temperature for a region. Okay? And this can be described as the long-term mean plus variations. And you might have one oscillation called mode 1, which influences your temperature. But you might have another mode 2 as well, plus maybe some additional features. Okay? So this is what we call decomposition. Again, decomposition, this method is very important to understand the variability. Okay? So now another thing, these modes that are shown here, the weight of these modes, the weighting of these modes is location dependent. So this mode A might only operate in the tropical Pacific Ocean, largely, and the mode 2 might be more significant in the North Atlantic. Okay, and you can work out the weightings of these modes from data. Okay? And that's how you can split up the climate variability that you observe into different modes of climate variability. And it's just illustrated here in a little made-up example. Okay, so just have a look at that time series that I show you above my head. Have a look at this time series. Okay, it shows some value. You just imagine that it's temperature, and you can see it has some oscillations and going up and down. And you can see different features. Looks very, very complex, but you can actually decompose it. And this signal here is actually made up of 4 individual signals that are shown here on the left. It has a mean trend, mean value and trend. So you can average that, you get the mean value, but the trend is the change. You can see that it increases over time. This is the trend. Plus, you have one mode, which is an oscillation of a certain period and certain amplitude. And you have another mode, mode 2, which is shown here too. And then you might have some random noise sitting on top, some random features. And if you add them all up, you come to that observed signal. Okay, and this is the decomposition. That's the decomposition of expressing a signal by specific modes, including a mean value and the trend. Okay, that's also an important part of that signal, because that trend, this is something that we interpret as the global warming signal if it's a temperature time series, something that increases. Okay. All right. So, is that all? Not sure. No, we have just a list of the key modes of interannual climate variability. Okay, here we are, key modes, NAO, ENSO, and the IOD. Okay, these are the key modes. And the second part of the lecture will introduce you to these modes, to teach you a little bit how they look like. Okay, and what's involved in this variability. And we also want to know what is a climate index. Yeah. And just saying it again, climatic modes. A climatic mode oscillates between a positive and a negative phase. Okay? Positive and negative phase. And the climatic index is a parameter that measures the state of a climatic mode. It's something that we derive from observations, from data, that we can tell whether that mode was in a positive or in a negative phase. We can reconstruct this variability. There's 2 different types of indices. One is based on atmospheric measurements, usually based on air pressure data from weather stations, with data spanning often more than a century. Okay. We also have ocean-based indices that are typically based on sea surface temperatures. Okay, but high-resolution satellite data are limited to the last 40 years, so we don't have that long time series. But I show you examples. I will show you examples. And this concludes the first part of this lecture.